Hello.
Hey, how's it going?
Pretty good.
Okay. Okay. So part two. What is the shape of the distribution of x?
Well, we're probably gonna need the little app thing again.
The what?
That little app thing again.
Oh.
That makes the graphics.
The app was in like lesson 5?
Yeah, I think so.
Oh, here it is. I think it's looking for like normal. Because
Yeah.
what is the shape of the distribution of x?
Yeah, for 4 and 5, I just think they're both normal because it's saying originally that it's normal, so the sample size shouldn't matter, right?
Yeah. Okay.
But then number 6, I have no idea what it's asking.
What?
Maybe, let me see. Oh, okay. I think I know how to do it. I think you put 40 in to the z-score formula.
Mm-hmm.
So for sample means that's the value minus the mean over the standard deviation, and standard deviation has to be standard deviation divided by or times the square root of n. I can't remember.
Um, divided by.
Yeah. So. Okay, I'm getting the z-score is -1 or 6. So I think we'll just stick that into the app. And then, so if it's only on the left side for less than, then like 15.87%.
15 point. Oh.
So that makes sense.
So you would put -1 in for the z-score?
Yeah, because I just used 40 as the value to put into the z-score formula.
Uh-huh.
Um, and then it's asking for the probability of whatever to be less than 40. So I just put the z-score -1 into it, and then
Oh.
so right there at -1 would technically be the number 40 on the graph, and then like under that, to the left of it, should be the percentage that'll be less than 40.
Okay, got it.
Hopefully that's what it's asking.
Yeah, I just forgot to unclick the other blue one. So.
Oh, yeah.
Okay, that makes sense. So for number 7, what would the x be?
In the z-score formula,
Yeah.
you have to find the z-score for 35 and 55.
Ew.
Yeah. And then you do, like for 55, find the z-score, and then find everything to the left of it, that percentage, and then you do that minus everything to the left of the 35 z-score.
Oh, okay.
Yeah. So this is like all the same as the other lesson, but it's just, it got confusing because it's like, now it's talking about the sample mean distribution,
Yeah.
but it's like all the same way mostly.
Okay. So we have to do the formula for both 35 and 55, and then I got -2 and 2. Is that what you got?
Yeah.
Okay. And then from there, you put it in the applet?
Yeah. So start with 55 z-score, which is 2, and put it in the app, and then make sure that the only thing that's blue is to the left of 2.
Okay. And then
the percentage is what?
What?
What's the percentage that is showing you?
The percentage is 0.0228.
Oh, okay. So that's the one for 35. So, like the z-score for 35 is -2, right? And then the z-score for 55 is 2.
Yeah.
Okay, so when you have everything to the left of 2 highlighted, it should be like 0.9772.
Oh, okay, yeah.
Yeah, and then when you have everything to the left of -2 highlighted, then that's the 0.0228. And then when you subtract that from the first one, that should be your answer.
Okay, so 0.9544?
Yeah.
Okay. Thank you.
Yeah, it all just depends on like if the question wants greater than a number, like in between a number, or less than a number.
Yeah. Okay. And then 8 is the same answer, right?
What?
8 is the same answer, the 0.9544.
No, I got 2 different answers. Let me see something really fast. So what z-score did you get for 41 and 49?
I got -2 and 2 again.
It should be 0.08 and -0.08. Did you see that the n equals 25? It changed to 25 instead of being 4.
Yeah, so the equation would be 41 minus 45 divided
Mhm.
by 10 divided by the square root of 25. And then you
Yeah.
change it to 41 minus 49. No, no. It would be 49 minus 45.
Yeah.
Hmm.
Is it? Are you still getting 2?
Yeah.
Hmm. Try. Maybe it's just your calculator needs more parentheses or something in order to make sure that it types the right thing in.
Yeah.
So yeah, so 49 minus 45, that's 4. Then I do divided by parenthesis 10, um, divided by square root, and the square root automatically puts a parenthesis around it for me, but I don't know what your calculator does.
Mhm.
And yeah, then 25. Oh, what? How am I getting 2 now? Okay, yeah, that's weird. What? Okay, now I'm getting 2. I don't know. I don't know what I did. Okay, then yeah, it's the same.
Weird. So it's the exact same answer from number 7?
Yeah, yeah.
That's weird.
That was weird. I don't know how I got a different one before. It was like hanging out like that the whole time, and then it like
Yeah,
changed.
that's
Weird.
weird.
Okay.
Okay. And for number 9, I got 0.0062.
Okay, I'm redoing that one because I think that something went wrong for me on that too. So.
Okay.
Mm. Okay, was your z-score 2.5?
Yeah.
That's it. Weird. Yeah, so 0.0062 is how you got.
Mhm.
Okay, cool.
Perfect.
Um,
So, how do you find out like what heat they are with just knowing N?
how do you find out what?
How do you find out what shape they are? By just knowing N.
Because lesson 6 talked about how big N has to be in order for it to be normal.
Oh, yeah.
It all depends on like the parent population. So like in the information they give you originally, like to start solving, they'll say like, oh, it's right skewed, and then they'll tell you, and then like in the question it'll ask, well, what's the distribution going to be like if the sample we take is N equals 5, and so it's not going to be normal because it has to be at least 30.
Okay.
10
would be right skewed.
Yeah.
And then 11 would be approximately normal.
Yeah.
And 12 is central limit theorem.
Mhm.
For 13, it would be no, right?
Mhm.
Come in.
Hey, I got you a present.
Really?
Got it in the fridge, though.
Okay. Is it boy? Okay. And then for 14, we just put it in the equation again.
Yeah.
So I got the z-score as negative 5.1. Is that what you got?
On what number?
On 14?
Let me see what I got. And wait, what did you say you got?
Negative 5.1?
I got negative 1.75.
Oh, I was using the information from the other one.
Oh, okay.
Let me do that. Okay, negative 1.75.
Yeah.
And then clear. So do okay, so did you get 0.9599?
Mm-hmm.
Okay. And then for the last one, 0.7887.
Sorry, what?
For number 15, would it be 0.7887?
The final answer?
Yeah.
I got 0.028.
What Z-scores did you get?
0.035 and negative 0.035.
I got negative 1.25 and 1.25.
That is,
Mm.
what the heck? What am I doing wrong when I'm not paying attention? That's weird. Okay. Yeah, then that's it. I don't know what maybe I'm not like today. I think I'm not putting like a divide symbol in or something, and I'm just like multiplying by the square root. I don't
Yeah.
know.
No, the square root is tricky when you put it in a calculator.
Okay. Yeah. So, yeah. Okay, cool. I'm looking at the answers, and all those are right. So that's
Oh,
good.
cool. All right, ready for the test?
Yeah. So let's do this.
Okay, so for number 3, is it 0.175?
Yeah, I haven't actually put it in yet. I was confused by the question at first, but yeah, let me put it in.
Okay.
Oh man, I think that I put out of the applet thingy. Dang
Oh man,
it.
be back.
There we go. Wait, are you getting 0.1745?
Yeah.
Okay, yeah.
Then it says round to 3 decimal places, so 0.175.
Okay. Too many things open. I need to like close them. So there we go. So like,
Yeah. What? It says the standard deviation is 26.7, and then the mean is 177.6, but what would X and N be?
another way that is extreme. I have no clue.
The only other numbers that are there, like 48 commercial boat passengers. Oh, so 48 would be.
Oh, okay.
Huh?
Is it looking for us to find everything above 185 and everything below 177.6?
Says that is extreme or more extreme than what was observed. So yeah, it'd be above.
Yeah. 185. Wait, what? No, but that doesn't make any sense because then we don't have a mean to go off of.
Wouldn't the mean be 177.6? Would we
I
use
just
the
what?
sample mean? But they assume that the mean weight of passengers in commercial boats is 185 pounds, but the sample that they took was 177.6. So would we take the 177.6?
Yeah, I would consider that the mean, and then like use 185 as just like the number, but it's asking for like extreme on both ends. What is that? How do you find that without more information?
Either above or below the mean. What?
Yeah.
I didn't see
Is
that.
that like everything?
Yeah, I think so. That's what I would guess. Um, I would think that's weird because it says like two opposite things. It says that will have a weight that's as extreme or more extreme, but then it says either above or below the mean.
Yeah. Hmm. Okay, let me try something. Six point seven. Okay, the z-score, if you say that we're using 185 as the mean in this formula, and then 177 is the unit that we're using. So, because in the note it says we're not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as in the positive direction. So all I can conclude from that is that 177.6 is what they're talking about for the thing that we observed, you know?
Mm-hmm.
So if that is a certain distance away from the mean and they're saying it was lower, then that's lower than 185. So all I can figure out is that the z-score for 177.6 is negative 1.92.
That's what I got.
Yeah, so 1.92. So everything below that is 0.0274.
Yeah.
And then, okay, and then now we need to figure out, I think we just use, because it says that, but also values that are as far away from the mean in the positive direction. So I think that we just use the same z-score and what's like above the positive 1.92. You know what I mean?
Everything?
So below negative 1.92 and then above 1.92. So the middle, there's like a huge middle portion that'll still be white, but those two outer portions should be 0.0549.
Perfect.
So 0.055 should be the answer. Is that right? I'm pretty sure that's what it means.
Yeah. Makes sense. Is it the middle one? The distribution of the sample mean X?
Are these tests open note?
I think so.
Okay, then I'm going to look at one of the things in the chapters. And I think I know where the answer is, I just don't remember what it is.
Yeah.
chiller with this on.
What?
That's my mom in the background.
Oh.
I think I'm on to something, but I'm trying to like think through it.
Yeah. There's only like one area that talks about the.
Yeah, it's like, and it's not even from this chapter. It's like just the law of large numbers from the previous chapter, right?
Yeah. So I wonder if it would be cannot be determined.
Yeah, let's just put that. I don't want to think about it any harder.
It's exhausting.
Because I think you need one more number in order to determine what will happen.
Yeah, that's true. Decreases as sample size increases.
The law of large numbers for that.
Yeah. Okay.
Thank you.
Oh, so for this, for number 7, we don't need the n, do we?
Yeah, it doesn't give one.
Isn't there another? What's the other equation that where you just need the mean, standard deviation, and then
I think you just divide by the standard deviation.
divide by what?
I think you just divide by the standard deviation instead of doing standard deviation divided by the square root of n.
So it'd just be 160 divided by.
Well, 160 minus 150.8 divided by 8.8.
That's the standard deviation minus the mean divided by the number.
The number minus the mean divided by standard deviation.
Okay, got it.
Yep, 1.05 as your rounded answer.
1.0, yeah. Would it be 0.1469?
Yeah, that's what I'm getting. Oh my gosh, what the crap? My numbers lock like randomly turns off, and then like I'm like, why isn't this like?
Oh my god.
How much maybe a little bit. For sharing this one, so you no.
Okay, so 8 would be 0.147 rounded.
Oh yeah.
So, would we find the mean out of those numbers? Or
Let's see. What? Oh, yeah. So we take the mean of this and use that as our like number minus the mean that it gives us, the 150.8.
Oh, okay. Got it. Okay.
It's exactly the same. Did you get 160 as the mean?
Yeah.
Okay, then it's exactly the same.
Oh. Right.
Wait,
For 150.
isn't number 10 exactly the same also? Wait, 147.
Yeah. Wait, no, number 9 would be, it's asking for the z-score. So wouldn't it be 1.05?
Yeah, that's what I put.
Okay.
And then I think that 10 is the same as 8.
Wait, wouldn't we put, so the mean for the z-score is 1.05. Oh. Yeah. Huh. Oh, except it's round to 4 decimal places. 3.1471469.
Oh, good call. Wait, it's 1479?
1469.
Oh, okay. That's so random. Why did you switch it all of a sudden?
Yeah. Would that be approximately normal? Number 11?
Mm-hmm.
So what does that mean? The mean of the distribution of the sample mean? John.
For 12 and 13, I think it's just asking you to identify the mean and the standard deviation from the information it gives you.
So 12 is just 3.5 and 13 is 0.7?
Yeah. Okay, and then tell me what you get when you do 14 and 15.
Okay. Would be less than 3.7. So it's I got 0.3874.
On 14,
Yeah.
what was your z-score?
Negative 0.285. What did you get?
My z-score is negative 2.57, and then my answer was 0.005.
Okay. So it would be
3.3.
did you use the first equation, like x minus mean divided by standard deviation? But is it square root of
Yeah, where you have the n. Yeah,
Oh, okay.
because it gives you the 81.
And then 3.3, that's x, right?
Mm-hmm.
Okay, yeah, I got negative 2.57. Then whoa. And what was your answer?
For 15 or 14?
14.
0.005.
Okay, perfect. And then for 15, did you get 0.995?
Yeah.
Finally.
What in the world did we get wrong?
What the
Oh,
heck?
that's stupid number 5. What?
Oh, dang it, for number 13, I accidentally pressed the decimal twice. That's
How did I got something wrong also, but I don't know what I got wrong.
for 13. Oh, did you put 0.7?
Yeah.
I think she's looking for 0.7.
Oh no, I put 0.7.
Oh, then I have no idea.
Oh my gosh, what the crap. I forgot that mean is just equal to the mean, but the standard deviation, when it asks for the standard deviation, it's supposed to be 0.7 divided by the square root of 81. Like, that's the other standard deviation for this case. Like,
Oh my gosh, and it says it right underneath.
I know. Whatever. Oh my gosh.
Alright, cool. I'm just glad it's over with.
Yeah.
I'm done.
See you next week.
Yeah. Alright, cool. Bye.
Okay, bye.